Hello friends, सबको नमस्ते. So today in this video we will create a Yoga Asanas Classification model using a YOLO. You can see this is a result, final result we have of the model, and let me show you the data set. Okay, so this is the data. This is a data set which have only two folder, test and train. In train folder we have 47 asanas, you can say, for the classification, and let me show you one folder. Let me open it. So you can say these are the images, and you can say some images are similar but having a data augmentation. Okay, so let's get started. So before I will explain you the code, please like, share and comment, please. It's motivate me to make more videos like this. So let's get started. Okay, so first of all we will install gdown, which help to import you can say download the zip file from the Google Drive, from your Google Drive. Okay, so let me run this. Okay, so this is a link which we are using. When you will copy the share link, you have to paste the limited part of that share link, and after that you have to give the name of the zip file. Then you will use this gdown download. Your zip file will get download from your Google Drive. It's unexpected event. Let me solve this. Now let me run this again. Okay, so it's downloading. See here, zip file is getting downloaded. My zip file is of 5 GB. You can see it. Okay, it will take time, so please wait. After that we will unzip it. It's make sure that you will give a same name that is here also, that is here only. Okay, so it's compulsory. So let me run this again. Let me run this cell. We'll unzip the zip file and we will get the complete data set on which we can train our YOLO model. And for training the YOLO model, we use Ultralytics, which help to upload the pre-trained YOLO models. Okay, the model which we are using is that from Ultralytics import YOLO. The model which we are using is YOLOv8 and cls.pt. Okay, and just we have to use model.train. Then you have to give the dataset folder name, then epochs. The epochs which we want is 10, and image size will be 2 to 4. Okay, it's required that image size will be 2 to 4 or smaller. Okay, then the batch is 8, means when you will have a number of images, it will divide each image with the in the batches, and each batch have 8 images. As you can see, our data set is there. We have only 2 folder, train and test. In train we have a multiple asanas folder. It's around 47. Okay, now let me close it. Now see, here we are, batches 8. Now name here, what is this folder name? It is a folder name. When you will run this cell, you will get run folder. Inside the run folder you will get a classify folder, and inside the classify folder you will get one folder name. The name which we decide is this one, and inside this folder you will get a weight folder, and inside the weight folder you will get best and last weight files. Save true, yes, we want to save the model. Save period management means only save the best model weight. Okay, we do not want to save every epoch weight file. Okay, patience 20 means after every 20 epoch it will see that if there is any changes in accuracy or loss or not. If there is no changes in accuracy and loss, it will stop the training and will get the best model. Validation true, yes, we want to validate the model also, yes. And for that you can see we do not have a validation folder, but how we can how the model will validate it? Will validate on a train images. Okay, so this way we will describe the model.train. Now let me run this cell. We will our training will get started. Okay, you can see the run folder is created, and inside the run folder, cluster folder, inside the cluster folder, the folder name which we have decided, YOLO dataset YOLOv8n, and inside it you will get the weight folder. Okay, right now there will be no weight inside it because the training is not get started yet. Wait for the seconds, it will start. Okay, As you can see that the training gets started. Now let me show you that best and last is not visible yet now because epoch bug training is not completed. You can see it taking too much time. So let me I think so I have to stop this training because it's taking too much time for the tiny epoch. I already had a model. You can see, let me show you the model. See, this is a model which is trained on tiny epoch. So I will directly show you the result of this model. Okay. I have just shown you this just for the explanation purpose at how it's working. Okay. So it will take time. Okay, it's taking the time, too much time is taking. So now come here, but I have to explain this part. Hmm, let me upload the best.pt, the model which we have. Open it. Yes, okay. So let me show you the result of the model which is trained on TinyPoc. Okay. So wait for that. I will stop this training because it's taking too much time. When will this training will get completed, you have to just use this. You have to get this path of the model like this in run folder. Inside the run folder, classify folder. Inside the classify folder, you have to give the the folder name which we have decided. Inside the wait folder will be there, and you will get the best.pt. This way, you will load the model, okay, which is trained on the data set which you have, custom data set, and it will be tan. After that, you have to just give the you can say this test folder, okay, which have a 47 classes. Now, after that, we have to os.list directory basically give me the list of all the folder name inside the test directory. Now I have to represent 16 folder. For that, I have to use figured plot or subplots. 4 by 4 means 4 columns and 4 rows. Figure size of each you can say subplot will be 16 by 16, and figure basically representing the entire subplot, and x is just for the iteration over the subplots. X dot rebel here, x is in a 2D format. When you will use x dot rebel, it is converted into 1D format just for the easy of iteration. Then I have to for plotation of 16 images, I have to use 4 ideas in range 16, means 16 times the folder will be run. Okay. Now after getting the folder name, I have to select the random folder name. Okay. This way I will get the random folder name. After getting the random folder name, I have to select I have to make the list of all the images present in that particular folder. For that, I have to use OR list directory. Then I have to create the path of that. So here, this is the path of the folder inside which I have to make I have to list all the images name, you can say. And for that, I have passed the text images. You can say this one, test image directory, then the folder name which I have decided. Okay, this way I create the folder name, and os.list directory give me the list of all the images in that particular folder. Okay, after getting the folder name, after getting the list of all the images present in that particular folder, I have to make the path of image. For that, text image directory, then the folder name, then random choice of the images. Okay, so this way we are randomly selecting the folder name also, and random selecting the image present in that particular folder. Okay, now I have to read that image, then I have to just pass that image to the model. Okay, after passing the image to the model, we have to get a result. For getting the result, we have to use zero index value because we are just passing the single image. To get the result of the single image, just use result of 0. You will get the single image. You can say result of all entire data of that particular image, and you can see the prediction, you can say. Now after, for getting the class ID, you have to use result.prop.top1. Top1 accuracy give you the class ID. You can say we have 41 classes, so 41 values will be there, or you can say 41 values. You can say 41 values probability. You can say accuracy. You can say a percentage value. So according to that, you have to get top one accuracy or top one probability. For getting that, we have to use result.prop.top1. After getting the class ID, just use model.name class ID. You will get the class name of that particular you can say of that particular image, or you can see the prediction we can give. Now after getting, we want also the confident, how much the model is confident that a particular image belong to that particular asana. So for that, we have to use result.prop.top1 confidence.item. Give me this confidence value. After getting the confidence value, I will convert that image into RGB, because we are reading with CB2, means we are reading the image with OpenCV, so it will read the image in BGR formats. So I have to convert that into RGB. So that's why it's after that, after complete process, after model prediction, we convert that into you can say RGB for plotting, or you can say I am sure. For that we have to use CB2.CBT color. Okay. After that we will just plot the images, and after that we have to first actual, means what is the actual prediction of that particular image. Actually total what is the image belongs to, that it is decided by the folder name which we have decided. It is a folder name which decide that what the particular person belong to. Okay, now prediction will be decided by the class name, so that's why we are using class name here. And the confidence it is, you are using this 0.2 at, means we will just 2% 2 means you can, let me show you. Okay, so 0.25 means after point only two value will be visible, that's why 2f will be there, and font size will be 12. Okay, so let me run this now. I think so my base model is also uploaded. I Okay, one epoch completed. So let me stop this. I will show you the result of the model which is trained on just one epoch. Okay, let me show you this. Okay, best and last. So now let me show the result of the model which is trained on just one epoch. Okay, wait for the second. Node such directory. Which one? Okay, let me show you. Let me show you. I think so. The problem is the folder name. YOLOv8, YOLOv8, and here we have YOLO-v8 and 2 will be there. So this is a problem. So let me run this again. It's now going. Now let me zoom in. You can say model one error is here. Oh, sorry, too much zoom. 2 error and 3, 4, 5, 6, 7, 8, means among the 16 images 8 predictions are wrong. So it might, I think so it's pretty good that a model is trained on just one epoch and it's performing very well. Now let me show you the result of the model which is trained on 10 epoch. This is a batch.pt which I have uploaded. So let me upload this model and let me run it again. Okay, just change the you can say change everything, remain the just batch.pt. Now let me run this cell. Now you will see the result of the model by just trained on tan epoch. Okay, see the result. Every predictions are same. Okay, no error, nothing. Yes, this one is problem. One error is here. One prediction is wrong. Okay, 2, and this is 3. This is 4, 5. Okay, among 16 5 predictions are wrong. Okay, now if you will train on 11 or 20 epoch, the accuracy will increase. Okay, so this way you will download this model now. After training the model with the 20 epoch or more than 20 epoch or 10 epoch, you will download this model, a model which have a greater accuracy. You can say as a number of epoch increases, accuracy increases, but at certain time, certain epoch value, accuracy might be not increase. It will stuck. Okay, so you will download that weight file and you will reuse it anywhere you want. Okay, so please, I'm explaining each and everything line by line, and you can say with a bit detail. Okay, so please like, share and subscribe. Thanks to all.